Alright, so my topic is combining and decomposing expressions with logarithms. So the two main things that we're going to be going over is how to deal with multiple logarithms in the same expression and how to evaluate logarithms with a base other than 10 or e. So, how do you work with logarithms in the same expression? There are three different properties that can simplify expressions: the product property, the power property. So the product property states that the log of two factors is the same as the log of the first factor plus the log of the second factor. So for example, log of 11x, it's log of 11 times x, so therefore it would be equal to the log of 11 plus the log of x. And you can do the same thing in the reverse. Log of 4 plus log of x plus log of 2. All you have to do is multiply those all together, and you get log of 8x. So the quotient property is pretty much exactly the same. However, instead of adding the logs of the factors, you are subtracting it. So log of 4 divided by x would be the same as log of 4 minus log of x. Similarly, log of 6 minus log of 2 would be the same as log of 6 over 2 or log 3. Now the power property, if you have the log of something raised to an exponent, you can take that exponent and just put it right in front of the logarithm. So log of 8 is the same as log of 2 to the third. Take that exponent of 3, bring it out in front, and you get 3 log 2. Same thing in reverse. 4 log 3 is the same as log of 3 to the fourth, or log 81. So, decomposing logarithmic expressions. So here's an example of one where you need to use multiple properties. So you have log base 5 of 4x squared over y. The first thing you're going to do is separate the 4x squared and the y to get log 5 of 4x squared minus log 5 of y. Then the log 5y is as simple as it can get. However, with log base 5 of 4x squared, you can still expand it a little more and get log base 5 of 4 plus log base 5 of x squared minus log base 5 of y. The only thing left to do is to take that 2 exponent and bring it out in front of the log base 5 of x. And there you go, you've gone from log base 5 of 4x squared over y to 3 different logarithms that make it much easier to evaluate. So, one more example. This one's a little more complex. However, if you take it one step at a time, you see those two terms are being divided, the 2x squared over 2 to the third, and x over y squared. So you separate those and subtract from the other. Then you take the exponents and put it out in front. So you get 3 log 2x squared over 2 minus 2 log x minus 2 log y. Then you take the exponents out again, and you get 2 times 3 log of 2x minus 3 log 2, which you get from separating in that term over there, minus 2 log x, 2 log y. And then multiply through in that beginning part, 6 log 2x minus 3 log 2 minus 2 log x plus 2 log y. And then you're going to separate the x from the 2 over there, 6 log 2 plus 6 log x, and the rest is all the same. And then you combine like terms, and you end up with 3 log 2 plus 4 log x plus 2 log y. So you can do the same thing in the reverse to combine logarithmic expressions. So let's begin with 3 log y plus log 2 minus log x plus log 3. So you take the 3 exponent, put it in front. That's the first step. Then you're going to combine. So the log 2 plus log 3, you'll multiply that and get log 6. So log y cubed plus log 6 minus log x. Then combine it again, log 6y cubed minus log x, and you end up with log of 6y cubed divided by x. So the second major part is how to evaluate logarithms that have a base other than 10 or e. You'll do this using the change of base formula. So you take, here's the formula, but basically you take the, I believe it's called the argument, you put the log of and whatever base you want to change it to, and take the number that you're taking the log of, so that would be the a, and divide it by the logarithm with the same base that you're trying to change to of the original base. So for example, you begin with log base 9 of 27. They're both powers of 3, so it would make sense to change the base to 3. You take log base 3 of 27, that argument, and divide it by log base 3 of 9, the original base. So, and then you could work with each one individually, so you know that log base 3 of 27, you're going to want to find that first. So if you put that into exponential form, you get 3 to the x is equal to 27, and that gives you 3. 3 to the third is equal to 27. And you're going to do the same thing for log base 3 of 9, set it equal to a variable, put it into exponential form, and if 3 to the x equals 9, x equals 2, 3 squared equals 9. So now that you know that the numerator is equal to 3 and the denominator is equal to 2, you know that log base 9 of 27 is equal to 3 over 2. That's it. Any questions?
No, I don't think it.
Let me ask you, how did you become so good at presenting?
Practice.
Thank you. I never practiced class.